To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all the rest of the MCQ questions of the O-Level 2020 paper. So we started off the paper 1, that is the multiple choice type questions, and in the first 2 chapters I discussed the first 27 questions. So now I am going to start with the 28th question. So 28. What is the part common to the human digestive system and the human respiratory system? So if you look at the answers, mouth, esophagus, pharynx and larynx. So we will try to understand this in the next slide. Now here I have put these 2 diagrams. You all can remember, students, our digestive system starts with the mouth cavity, and it ends with the anus. Whereas our respiratory system starts with the nostrils. Those are the openings and they end with the lungs. They only have one entry of the gases and the exhaling of gases. Both inhaling and exhaling occurs through the nostrils. So that is the respiratory system. Now if you take this diagram, here you can see, students, this is the mouth cavity. So here the epiglottis is marked, but here you can see this side. Now in this diagram that is of course marked. Normally we use the buccal cavity or the mouth cavity to eat. So when the food goes in there, then this part, this pharynx is here. Now you can see the pharynx part, that is this part is pharynx. Now here from the mouth also, when you look at the digestive tract, pharynx is here. After the pharynx, we have the esophagus, that is a tube-like structure. So we have the buccal cavity or the mouth cavity, then we have the pharynx and then the esophagus. The same way, if you take the nasal cavity, now here see, this is the nasal cavity. Now this part is the nasal cavity. Now the nasal cavity also comes and ends with the pharynx. Then thereafter, here we have, now this part, now here you can see, students, this part is the respiratory tract, and here from the mouth, this side is the digestive tract. The arrow that is shown is the respiratory tract. So the larynx part is here. Larynx. So here you can see mouth is there, then this is the esophagus, then larynx is there only with the respiratory tract. But if you take the pharynx, it is common to both the digestive tract. Here you can see food goes this way. That is the digestive tract. Pharynx is there. The same way here the respiratory tract also, here the pharynx is there. So pharynx is common to both the digestive system and the respiratory system. But larynx is there only with the respiratory system. Mouth and esophagus, they are part of the digestive system. I'm sure you all can understand that. So then, if we answer the question, here you can see what is the part common to the human digestive system and the human respiratory system. Common to the human digestive system and the human respiratory system. Mouth, esophagus, like I said, both of them belong to the digestive system. Pharynx is common, larynx belongs to the respiratory system. So the answer is pharynx. Is that clear, students? Then I'll move on to the next one. Question number 29. The figure shows a couple of forces is applied to rotate a wheel of 0.4 meter radius. So here there is a couple of force and the radius of the wheel is 0.4 meters. Now if you look at the diagram here, the wheel is shown there. The 2 forces that are acting on it are 5 Newton forces, and here this part, the radius is 0.4 meters. So what is the distance between these 2 points? If the radius is 0.4, this has to be 2 times 0.4. 2 times 0.4 meters. So that is going to be 0.8 meters between the two couple of forces. Now it is a couple of forces. You all can remember that. Now if we have a structure like this, where you have the moment of force, then what do? We take this distance and this force. Here F1 into D1 will be the, if we take this as D1, F1 into D1 is going to be the moment of force. That is this direction, anti-clockwise moment of force. The same way on this side also you can have, if this is D2 and F2, here you will have F2 into D2, that is the moment of force. Now here we consider from the point of rotation. That is if there are two moment of forces. But there it is a couple of force. So then what do we need to consider? We need to consider the line of action of one force, the line of action of the second force, and the distance is the distance between the two forces. So that is going to be this distance. That is 0.8 meters. So if you are to find the couple of force, here look at the question. How much is the moment of this couple? So moment, you need to consider the force and the total distance between the two lines of actions of forces. So 5 Newton into 0.8 meters. That will give you the moment of this couple. Is that clear, students? Moment of force, from the point of rotation, you consider the distance to the force. But moment of the couple, you need to consider the distance between the two forces. Is that clear? So then, if we look at the answers, 5 into 0.4, no. That is only half the distance, the radius. 5 into 0.8, that is correct. And 5 into 0.8, no. We only take one magnitude of force. 5 into 0.8, that is also not correct. And in all the answers, you can see the unit Newton meters. Why? Force is newtons, here you can see, and the distance is meters. So the answer here is 5 into 0.8 Newton meters. So you have to remember, students, when we consider the rotation of forces or the turning effect of force, we look at two things. One is the moment of force, where you have an axis of rotation and a force acting and there is rotation. Here, of course, it is counterclockwise or anti-clockwise rotation. If you are to find the moment of the force here, force into distance between the force and the point of rotation. But when it is a couple, you need to consider the force and the distance between the two forces. You have to keep that in mind. Is that clear, student? So then, I'll move on to the next question. What is the mole fraction of oxygen in a mixture containing 96 grams of oxygen gas? So, there is a mixture. The mixture has 96 grams of O2 gas and it has 56 grams of N2 gas. So, what is the mole fraction of O2 in a mixture containing 96 grams of oxygen gas and 56 grams of nitrogen gas? The relative atomic masses are given: nitrogen 14, oxygen 16. So, to find the mole fraction, you need to know the number of moles. So, to find number of moles, what do we need? If it is for oxygen, number of moles of oxygen, 96 grams is the mass of oxygen. But here, if you are to find the molar mass, oxygen is 16, but it is an O2 molecule. So, 2 times 16. 2 times 16. So, that is 96 divided by 32. So, that is going to be 3 moles. The same way if you find the number of moles of nitrogen, because we need to find the mole fraction. So you need to know the number of moles of all the components there. So here nitrogen, 56 is the mass of nitrogen, but relative atomic mass 14. But nitrogen is N2. So 2 times 40. That is going to be 56 divided by 28. That's 2 moles. So what is the mole fraction? If you find the mole fraction of, we need to find oxygen. Oxygen 3 divided by 3 plus 2. That is 3 over 5. Is that clear, student? So that is the mole fraction. Now one thing, I have calculated the moles and substituted the value. If you are familiar with the calculation, in the mole fraction itself, you can directly substitute and calculate. But this gives a more simple calculation, because initially we find the number of moles and then we find the mole fraction. Is that clear, students? Mole fraction means mole of one component divided by the sum of the number of moles of all the components present in a mixture, all the constituents present in a mixture. So here it is only oxygen and nitrogen. So moles of oxygen divided by moles of oxygen plus moles of nitrogen. Is that clear? So the answer is 3 by 5. Third answer. So that is the answer for the 30th question. Then 31. Given below are 4 ways by which zinc metal and hydrochloric acid were reacted at room temperature. In which way is hydrogen gas liberated with the higher speed? So here you need to understand this is related to the rate of reaction. Zinc granules dilute hydrochloric. Then zinc granules concentrated hydrochloric. Zinc powder dilute hydrochloric and zinc powder concentrated hydrochloric. Now we'll try to understand this. Here I have put some diagrams. In all these we have the zinc metal. Here we have zinc in all the test tubes. Now here you can see these are zinc granules, and that is in the first one dilute hydrochloric, second one concentrated hydrochloric, third one zinc powder with dilute hydrochloric and zinc powder with concentrated hydrochloric. So there are 2 factors considered here. When we say granules and powder, what is the factor there? Granules, powder, it is the surface area. Surface area. Now what happens when surface area increases? When the surface area increases, when you make the zinc granules to powder, surface area increases. Therefore, more reactant particles are exposed to each other. More zinc is exposed to hydrochloric acid. Therefore, the number of collisions in a unit time increases. Thus, the rate of reaction increases. Now, if you take this set and this set, here we have zinc powder. So, because of zinc powder, the rate of reaction will be higher. But at the same time, we need to consider the concentration of the reactants. The second factor is concentration. Now, concentration, how does it affect? When the concentration increases, again the number of reactants in a unit volume of the mixture is greater. Therefore, the number of collisions in a unit time increases. Thus, the rate of reaction increases. So, the highest rate of reaction will be when you have zinc powder and concentrated hydrochloric acid. If you compare all these, now dilute hydrochloric acid with zinc granules will be the lowest reactivity. Then we have concentrated hydrochloric acid and granules, but dilute hydrochloric acid and zinc powder. Those two, depending on the concentration and how tiny the granules are, these two will have different rate of reaction. But the highest rate of reaction will be this one. The highest will be this one. Why? We have concentrated hydrochloric acid, concentration is high, and zinc powder. So that means the surface area is also high. So because of that, in the fourth one, the rate of reaction will be the highest. Is that clear? So there, if we answer the question, given below are 4 ways by which zinc metal and hydrochloric acid were reacted at room temperature. In which way is hydrogen gas liberated with the highest speed? So with the higher speed, zinc granules dilute hydrochloric acid, zinc granules concentrated hydrochloric acid, zinc powder dilute hydrochloric acid, zinc powder concentrated hydrochloric acid. So that is where the surface area is high, at the same time concentration of reactant is high. And you all know, here they have said evolving of hydrogen gas. How does that happen? Zinc solid plus HCl aqueous. When that reacts, you get ZnCl2 zinc chloride aqueous plus H2 gas liberating. So you all know the equation also. We can balance it as well. You need to put a 2 here. So zinc solid reacts with hydrochloric acid to give zinc chloride solution and hydrogen gas. So that's the reaction. Is that clear, student? So then we'll move on to the next one. 32. Between a strong acid and a strong base. Now here 2 things. One thing it is acid and base, the other one acid and strong base. What is an acid? You all can remember, we can use a common equation. If we take HA as the acid in the aqueous solution, this completely dissociates to give H plus aqueous and the A minus aqueous. Say if this is hydrochloric acid, H plus ions and chloride ions. If it is nitric acid, H plus ions and nitrate ions. Or if it is sulfuric acid, H plus ions and sulfate ions. Always they give rise to H plus ions, then it is an acid. If it is a complete dissociation, then it is a strong acid. Strong acid. The same way strong base, like say, we can write it as BOH, for example, NaOH. That again in the aqueous medium, when you dissolve it in water, completely dissociates to give B plus ions and OH minus ions. H plus and OH minus ions. H plus is given by strong acids, OH minus is given by strong bases. So here H plus is given by strong acids and OH minus is given from strong base. When they both react together, what happens? HA plus BOH gives rise to BA, B plus and A minus and water. As an example, if we take HCl plus NaOH giving rise to NaCl and water. So here also aqueous, NaCl aqueous, water liquid. Aqueous and water liquid. This is the reaction. What is this reaction? Here you can see it is a double displacement. H combines with OH, Cl combines with Na. So that's why we have NaCl and H2O. So this is a double displacement reaction. And also we have done reactions like this in the lab. You all know when this happens, there is heat released. So in addition to this, there is the release of heat. By the reactants have more energy, the products have less energy. With this, heat is released. Energy is released. So because of that, what do we call this? It is an exothermic reaction. So here, if we identify the type of reaction, we can say this is a double displacement. Double displacement. It is exothermic. And also because there is H plus and OH minus, we have H plus, then OH minus, combining to give water, their neutralization happens. Because of that, we call it acid-base neutralization. Acid-base neutralization. So the above reaction between a strong acid and a strong base is usually a double displacement reaction. It is exothermic, releases heat, and also it is known as neutralization. Neutralization, N-E-U-T-R-A-L-I-S-A-T-I-O-N or Z-A-T-I-O-N, both can be used. So now, if we answer the question, between a strong acid and a strong base, an exothermic neutralization reaction occurs. An endothermic neutralization reaction occurs. An exothermic combination reaction occurs. An endothermic combination reaction occurs. The correct one is an exothermic neutralization reaction occurs. So it has to be neutralization and exothermic. Is that clear, student? So you can remember, if it is an exothermic reaction, the reactants have higher energy, products have less energy. So the reaction goes from reactants to products, then heat is released. You all can remember that. You are familiar with the energy level diagram as well. This is how we draw it. You have NaOH aqueous plus HCl aqueous. They are the reactants. And so this is going to be the energy. Here, energy released. So here it is going to be NaCl aqueous and H2O liquid. So those are the products. Reactants have more energy, products have less energy. It is an exothermic reaction. Exothermic. Usually, the dissolving of acids in water, dissolving of bases in water, acid-base neutralization reaction, combustion, all these are examples of exothermic reaction. Even cellular respiration, where heat is given out. Dissolving of lime in water, calcium hydroxide dissolving in water, sodium hydroxide dissolving in water, neutralizing HCl with NaOH, or diluting acids. If you mix dropwise nitric acid into water to dilute it, that is also an exothermic reaction. So those are all exothermic reactions. Even metals with water, metals with acids, all these are exothermic reactions. So you know a lot of examples for exothermic reactions. I'm sure you can remember all that. With that, students, I'll move on to the next one. 33. A conductor carrying an electric current I is kept perpendicular to a magnetic field as shown in the diagram. So if you look at the diagram here, you can see. Now here, direction of the magnetic field is shown by the arrow. That is the conductor. And here you can see the direction of the current flow. This is the direction of the current flow. Current is this way. And the magnetic field is that way. Field. Horizontal lines indicate the direction of the magnetic field. The direction of the force acting on the conductor is. They want you to find the direction of the force. So, if there is a conductor placed in a magnetic field and when current is flowing through it, there is a force acting on it. How can you determine the direction of the force? We use the Fleming's left-hand rule. Based on this concept only, we have the direct current motor, the loudspeaker, the analog voltmeter, analog ammeter, galvanometer, all those are based on this particular concept. So, we use the Fleming's left-hand rule. Now, here, this is the direction of the force, that is the thumb. Then you have the index finger that shows the direction of the magnetic field and the middle finger shows the direction of the current flow. Now, here, of course, magnetic field is this way, in this direction. But the current flow, it is flowing upwards, like that. So, what is the direction of the motion? Thumb is pointed into the board, into the paper or into the board. So, here, toward the left on the plane of the paper, toward the right on the plane of the paper, into the plane of the paper, perpendicular to the plane. That is the correct one. Out of the plane of the paper, perpendicular to the plane, no. Here it is in. You have the field this way, current upwards. So, it's going to be like that. So, here you have the field this way, students, current going into the upwards. So, that means the thumb will be pointed inwards. So, the correct answer is into the plane of the paper, perpendicular to the plane. You all know all three have to be perpendicular. Field, current and the force will be all perpendicular to each other. Is that clear? So, then we'll move on to the next one, 34. Under normal atmospheric pressure, a pure block of ice at temperature minus 10 degrees Celsius was heated at a uniform rate until it was turned into liquid water. And then for some time after the water started to boil. Which graph correctly indicates the variation of the temperature of the system? So, initially the water is at minus 10 degrees Celsius and they say normal atmospheric pressure. Why have they mentioned that? You all know, students, boiling point, melting point of substances, they depend on pressure. Under normal atmospheric pressure only, we compare the values. So, for water, we say under normal atmospheric pressure, the melting point of ice is 0 degrees Celsius. Boiling point of water is 100 degrees Celsius. So, how does the state change occur? Before we look at the answers, we will just try to understand what happens there. So, if we plot a graph like that, initially you have the ice at minus 10 degrees Celsius. Now, this is temperature, degrees Celsius. This is 0. So, initially what happens when you provide heat, the temperature will, I'll use a different color. Here the temperature increases until it reaches the value 0. Now, at this point, what happens? The ice starts to melt. So, there, although we provide heat, there will be no change in temperature and the heat provided is known as the latent heat of fusion. So, at this point, there is melting and the heat provided is taken in as latent heat of fusion. After everything melts, what happens? Let's say the boiling point is 100 here. So, if I draw a broken line there, until the temperature becomes 100 degrees, there will be an increase in temperature. Thereafter, when we provide heat, the temperature will remain the same. There, the heat provided is absorbed as latent heat of vaporization. There will be no change in temperature. That will be the melting point. Thereafter, if you heat, there is again slight increase in temperature. So these points. Now here it's going to be melting. Now this is the melting point, 0 degrees Celsius, and here it is going to be latent heat of fusion. Heat of fusion. The heat absorbed. No change in temperature, there is melting happening. The solid becomes liquid. Then here again temperature of water increases. At this point, it is boiling. So this is the boiling point at normal atmospheric pressure. And here it is latent heat of vaporization. So there is no change in temperature. That is how the graph varies. I am sure you all can remember that. So initially ice, then at this point melting, then water. So here it is ice, here it is water, and here it is steam. Steam. The temperature of steam increases slightly because we are providing heat. Is that okay? So here, which graph correctly indicates the variation of the temperature of the system with time? Here also, it is at minus 10 degrees Celsius, then it melts to form the liquid water. Then after some time, after it starts to boil also, we have it for some time. Thereafter, the increase in temperature of steam is not considered here. So what should be the graph? Now first one you can see, they have the temperature constant at 10 degrees Celsius. That is not possible because they are heating the ice from minus 10. So the temperature has to increase. So at this point itself, there is a mistake. So here this part is not correct. Then here of course you can see from minus 10 to 0, then melting, thereafter to 100, then boiling. That is the correct graph. This one is the correct graph. Here what is the mistake or the difference? From 10 directly to a higher temperature, the temperature increases. The melting is not shown here. This part is incorrect. Then here they have shown this part correct until the temperature of ice increases, melting, temperature of water reaches 100, but thereafter they provide heat for some time, the boiling. That is not shown here. So here the boiling is not shown. So that is why this graph is correct. It includes all the information. Is that okay, students? So you have to remember this. Then with that we'll move on to the next one. Question 35. Consider the following statements presented regarding natural rubber. So you all know rubber is a polymer. There are two types of rubber. One is natural, the other one is synthetic. So here they have given some statements regarding natural rubber. A, it is a linear polymer. B, isoprene is the monomer. And C, there are cross-links among the chains. Of these statements, the answers are only A is true, only A and B are true, only B and C are true, only A and C are true. So we will try to understand that. It is a linear polymer, isoprene is the monomer, there are cross-links among the chains. Now to understand that, I have put the molecules so that you can see. Now this molecule is the monomer of natural rubber. This is isoprene. You know isoprene is a 5-carbon hydrocarbon where there are two double bonds. You can see the first carbon CH2, then double bond C. In that there is this CH3, a side chain, and then you have again a CH group, double bond CH2. When there is polymerization, you all know students, this double bond is given here while this double bond is given to the next molecule. So therefore, there is a change in the position of the double bond when polyisoprene is formed. Polyisoprene. Polyisoprene is the natural rubber. So here you can see the position of the double bond has changed. You have CH2, C, CH3, double bond CH, then CH2. That is the repeating unit of rubber. So when there are n number of such molecules, it is the polyisoprene or the natural rubber. Now, if you look at this chain, there are no cross links. Although there is a tiny branch like that, there are no cross links. So it is a linear polymer. Now this is the rubber, this is linear polymer. Linear polymer. You can remember this is based on the structure, linear polymer. But when you react it with sulfur, you can remember, you get vulcanized rubber. With sulfur, there are cross links formed between the chains of rubber. Polyisoprene, between polyisoprene molecules, there are side cross links formed. Now these are the cross links. That is only in vulcanized rubber. Now the normal natural rubber is a linear polymer. So now if we look at the statements given, I am sure you all can find the correct ones. It is a linear polymer, correct. Isoprene is the monomer. There are cross links among the chains, that is incorrect. This is true only if it is vulcanized rubber. So regarding natural rubber, it is a linear polymer and the isoprene is the monomer unit. So of these statements, only A is true, only A and B are true. Only B and C are true, only A and C are true. So out of that, the correct one is only A and B are true. I am sure you can understand that well. With that, the next question. 36. Corrosion of iron can be controlled by keeping iron in contact with the bivalent metal M. What is the half reaction to which the metal M is subjected here? So they want you to find that metal. Now here corrosion of iron can be controlled by keeping iron in contact with the bivalent metal M. Now you can remember this, students. When we discuss the prevention of corrosion by placing iron with another metal, you have to consider the activity series. You can remember we have iron, we have magnesium, zinc, they are above iron. Then you have copper below iron. Now all these are bivalent ions. Now we can use Mg becomes Mg2 plus. Then zinc becomes zinc 2 plus. Iron also becomes iron 2 plus. And copper becomes Cu2 plus. These are all bivalent. You know the meaning of bivalent ions. Bi means two valency. So they are all 2 plus ions. Bivalent ions. Now out of these, you can remember reactivity of magnesium and zinc is greater than iron. So when one of these metals are in contact with iron, always these two act as the anode while iron acts as the cathode. So always iron will be protected because iron will not undergo rusting. And that is why we call it as the cathodic protection or sacrificial protection. These act as the sacrificial electrode. But if you try to protect it with a copper coating, so then what happens? Until the copper coating is there is no contact of iron with oxygen or moisture in the environment, then there will be no rusting. But if the copper coating is scratched and iron is exposed to oxygen or atmospheric air, then of course the rusting process will be accelerated. What is the reason? Here copper will act as the cathode and iron will act as the anode. So iron will undergo rusting. But either way, whether you use magnesium or copper, you can prevent rusting. That is, as long as the copper coating is intact, there will be no rusting. But always, when you have magnesium and zinc near iron, iron will not rust because magnesium and zinc, they act as the anode. I'm sure you can remember that. But in all instances, if it is magnesium or zinc, the reaction will be the metal will lose 2 electrons and form the bivalent ion. So, if we look at the equations given there, corrosion can be controlled by keeping iron in contact with the bivalent metal M. What is the half reaction to which the metal M is subjected here? So, here you can see it has to be the bivalent metal M, that has to be either magnesium or zinc. So, what will happen? The metal will become 2 plus ions, losing 2 electrons. So, you have M solid, you get M2 plus aqueous, losing 2 electrons. That is correct. M2 plus aqueous becoming M solid and losing 2 electrons, not possible. M2 plus aqueous gaining 2 electrons becoming M solid, that is a reduction reaction. Then of course iron will not be protected. Metal will be the cathode, iron will become the anode. Here M solid plus M2 plus aqueous plus 2 electrons, that also does not happen. So the correct equation is the first one, where the metal acts as the anode and iron will be the cathode. Because you all know anodic reaction is the oxidation reaction. So here metal loses electrons. So anode means, anode you all know convention, it has to be oxidation. Oxidation is losing electrons. Losing electrons. So the correct answer is this one. The metal S, that is the metal solid, becomes M2 plus aqueous, that is the solution, losing 2 electrons. Is that clear, students? So with that, I'll move on to the next one. 37. A 4 Newton force and a 3 Newton force are applied on an object at the same instant. Consider the following statements given about the magnitude of the resultant obtainable at that occasion. A. The maximum magnitude of the resultant obtainable is 7 Newton. B. The minimum magnitude of the resultant obtainable is 1 Newton. The magnitude of the resultant obtainable is always 5 Newton. Of the above, the correct statement or statements is are only A, only B, only C, only A and B. So we will try to understand that. Look at the values of the forces 4 Newton and 3 Newton applied on an object at the same instant. So here, if we take this as the object, how can you apply the forces? Now one thing, we can apply the force in the same direction. 4 Newton and 3 Newton. Then what will be the resultant? Because both the forces are in the same direction, they will get added up. Sum of the two forces, you will get the resultant as 7 Newton. If they act in the same direction, it can be either this way or you can have the force this way also. I will use a different color. Another instance, if you has one force this way, the other force this way, that also will give rise to the same resultant. Let's say 4 Newton here and 3 Newton there. Still the resultant will be 7 Newton. It's the same as this. So either you have them acting as parallel forces or with the same line of action but in the same direction. As long as the directions are same, the resultant is going to be the same. In another instance, now let's say if you have the forces acting like this. 4 Newton to one direction, 3 Newton in the opposite direction, where you have the line of action of the two forces are in a line. So here, of course, if you find the resultant, that is going to be higher value minus the lower value, difference between the two forces. So it is going to be 1 Newton towards this direction. In the previous one, 7 Newton, there will be the direction. Here both the forces act in the same direction. Here they are in different directions, but it will be, the resultant will be towards the higher force. So in one instance, if both forces act in the same direction, you can get the resultant 7 Newton. That is correct. If the forces are acting in the opposite direction, you can get the 1 Newton resultant force. But can you get a resultant of 5 Newton? That is not possible. So these are the possible ways in which these two forces can be applied to an object. So now if we try to answer the question, a 4 Newton force and a 3 Newton force are applied on an object at the same instance. Consider the following statements given about the magnitude of the resultant obtainable at that occasion. A, the maximum magnitude of the resultant obtainable is 7 Newton. Correct. B, the minimum magnitude of the resultant obtainable is 1 Newton. That is also correct. The magnitude of the resultant obtainable is always 5 Newton. No, we did not get 5 Newton in both any of the instances. Of the above, the correct statements are A and B. So the answer only A, only B, only C. It is only A and B. Is that correct? So with that, we'll move on to the next question. 38. A strong bar magnet is moved into and away from an insulated wire coil with a large number of turns as illustrated by the diagram. So if you look at the diagram, here you can see an insulated wire coil, and then you can see the magnet there, south and north, into the coil and away from the coil. That's how they are moving the magnet. Then here you can see the coil is connected here. There are two light emitting diodes. Here you can see these are LEDs. These are LEDs. Light emitting diodes. This is the symbol. Then there is the bulb also. And you can see the light emitting diode. This allows the current to flow in one direction. The other diode allows the current to flow in the opposite direction. But through the bulb, you all know the current can flow in any direction and it will light. So there, what is the correct observation about the instances of movement of the magnet? Now you can remember, students, we have done an activity like this. Now this is related to electromagnetic induction. What happens there? You need to have a conducting coil. You need to have a magnetic field. It doesn't have to be a conducting coil. You need to have a conductor and the magnetic field. Now, when the conductor is stationary, if you move the magnet, then the magnetic field lines will be disturbed. There will be a magnetic flux. Then due to that magnetic flux, there will be an induced electromotive force, which will make an induced current to flow. And if the circuit is complete like this, the current will flow through the circuit. And you can remember, depending on the direction of the motion, the direction of the current will change. At the same time, that is, when you move the magnet into the coil, the current will flow in one direction. When you move the magnet away from the coil, current will flow in the opposite direction. The same way, if you change the magnet, if you have north here and south there, then also the direction of current flow will change. So if you do all four instances, you can see the direction in current flow change. To identify the direction of the current flow, what is the rule we use? We use the Newton's right-hand rule. So, to determine the direction of the current flow, what is the rule we use? We use the Fleming's right-hand rule. Here also, the direction of the force is this, direction of the magnetic field, direction of the current flow. They all have to be perpendicular to each other. So, you can understand direction of the force and the direction of the magnetic field affect the direction of the current flow. Is that clear? So, that is the normal activity. Now, here we have two LEDs and one bulb. So, as you know, when you move the magnet into the coil, current flow will be in one direction. Then the bulb will light and one of the LEDs, depending on the direction of the current flow, will light. Because let's say if the current flows are in this direction, it will go through this and this. If the current flows in this direction, it will again go through the bulb and go through this LED. So, depending on the direction of the current flow, only one LED will light at an instance. So, let's say when you move the magnet into the coil, if this one lights, when you move it out of the coil, this will light. Is that clear, student? So, when you do the opposite movements, into the coil, magnet going into the coil, one LED will light. When the magnet comes out of the coil, the other LED will light because the direction of current flow will change. But the bulb, irrespective of the direction of the current flow, the bulb will light. You all can understand that because current can flow in this direction and this direction through the bulb. So, therefore, whenever there is a current flow, the bulb will light. So, when we move the magnet into the coil, current flows, bulb and one LED will light. But if you hold the magnet inside the coil, will there be a change? No. Why? Then of course, there is no magnetic flux, there is no induced electromotive force, therefore, there is no current flow. Again, when you move the magnet away from the coil, there will be deflection. Then of course, it will be in the opposite direction. The current flow in the opposite direction. So, the bulb and the other LED will light. Is that clear, students? So, now if we look at the observations. In both instances, both the bulb and two LEDs light simultaneously. That's not correct. Both LEDs can't light simultaneously. In both instances, the bulb lights and only one LED lights. That's correct. The bulb and one LED light only when moved into the coil? No. When moving out also it lights. The bulb and one LED light only when moved away from the coil. That is also incorrect. So, the correct answer is in both instances the bulb lights and only one LED lights. Is that correct? I am sure you all can understand that. With that, students, I'll move on to the next question. 39. Consider the following statements. A. Biomagnification occurs along a food chain. B. Toxic chemical pollutants concentrate more in the upper trophic levels of a food chain. Of the above statements, first one, both A and B are true. Second one, A is true while B is false. Third one, A is false while B is true. And fourth one, both A and B are false. Now we will try to understand this here. I have put the diagram, that is biomagnification. You know what biomagnification is. Accumulation of pollutants through the food chain where the amount of that toxic substance increases as you go up the trophic level. So, here you can see if there is a toxic substance, a pollutant, 0.000002 milligram per liters. When it gets accumulated in the water body, you can see the concentration increasing 0.005 milligram per liter. Then, if it is consumed by the planktons, here you can see 8 milligram per liters. Then some of the tiny microorganisms, they can consume that. Then it becomes 10 milligram per liter. then a starfish. It consumes these planktons or the planktons, algae. Then here you can see the starfish, there is more, 11 milligram per liter. Then the tiny fish, 37 milligram per liter. Then from there, if a bird consumes that, then you can see that is 110 milligram per liter. At the same time, here you can see in a seal, there is 160 milligram per liters. So, along the food chain, as the trophic level increases, the amount of that chemical substance or the toxic chemical substance or the pollutant increases. Why does that happen? Because these substances are known as bioaccumulated chemicals or substances. Now, what is the meaning of bioaccumulated? They don't degrade very easily. They don't decompose easily. They dissolve better in fat. So, in all these animals, usually the body contains fat. So, these substances can are soluble in fat and they will be retained within the body of the organism. If they were soluble in water, they can be excreted. But here, they are not soluble in water, so they get concentrated in water, and also they can be with food, it goes into the body of the organism and there it dissolves in fat. It is soluble in fat and therefore it is retained within the organism. So here bioaccumulated chemicals, and as they go above in the trophic levels, the amount of the substance increases. So these are the bioaccumulated chemicals, and within the body they can become active biochemicals as well. That is why they cause harm to the organism. So these bioaccumulated chemicals getting accumulated along the food chain and the amount increasing is known as biomagnification. Is that clear, students? So now if we try to look at the answers. Here you can see, consider the following statements. A biomagnification occurs along a food chain. That is correct. So that is what we understood now. No? It occurs along the food chain. Toxic chemical pollutants concentrate more in the upper trophic levels of a food chain. That is also correct. That is why the higher trophic levels or the upper trophic levels, the concentration is more. Of the above statements, both A and B are true. That's correct. A is true while B is false? No. A is false while B is true? No. Both A and B are false. That is also not correct. So, the correct one is both A and B are true. Is that clear, student? So, with that, I'll move on to the last question of this MCQ. So, here, question number 40. A statement displayed on a board near a tank is shown in the figure. Which of the following human activities in connection with the tank would have contributed most to the change mentioned on the board? Now look at the board. It is you who turn the water in this tank green. So when you say the tank, the water is green, you all can relate it. It is eutrophication. If you look at the answers, first one, clearing the area above the tank. Second one, increase in algae population due to fishing. Third one, accumulation of oil and grease due to vehicle wash. Fourth one, addition of fecal and excretory matter to the water. So, to answer this question, first we will try to understand what eutrophication is. So, here I have put this picture where there is an eutrophicated reservoir. So, this is how it looks like, greenish, greasy nature, oily nature. Completely the water surface is covered with green color. And normally you all know, if it is there for some time, you get a very bad odor also, very bad smell. What is the reason? Now here there are phosphate ions, phosphates and nitrates. These two ions are added to the water body by various factors. What are those factors? From industrial processes, industries, then by agrochemicals getting added to the water body, agrochemicals, then there is the fecal matter, and also industrial waste, agrochemical, fecal matter, and detergents, from detergents. Now, from all these four methods, both the phosphates and nitrates are added to water. Then what happens? There is an excess growth of algae. Excess growth of algae. Now, when excessively algae grow, they cover up the surface and it becomes like a foamy surface. Then what happens is light cannot penetrate into water. Underwater also, some of the organisms start to die because there will be no photosynthesis. The food chain will be disturbed. Inside the water also, organisms start to die. At the same time, because of this excess growth of algae, there is an overpopulation of algae, then these algae start to die. Now, these are the dead algae. And on this dead algae, anaerobic bacteria start to decompose this dead algae. And when that happens, what will happen is there are a few gases evolve. Hydrogen sulfide, methane, and also ammonia gases are released. So, this is the process. There are the waste materials from industries, agrochemical, fecal matter, and detergents. When they are added to water bodies, in that there is phosphate and nitrate ions. Now, due to these phosphate and nitrate ions, there is an excess growth of algae. And due to that, they completely cover the surface of water. They become like a foamy layer on top of water. And then there is overpopulation of algae. Because of that, there is too much of competition. At the same time, light cannot penetrate into the water body. So, there is a disturbance in that aquatic ecosystem. Then, because of the overpopulation, the algae, there is too much of competition. Because of that, they start to die. And on these dead algae, there are anaerobic bacteria that act on it. And due to that action, hydrogen sulfide, CH4, that is methane, and ammonia are released. Now, these H2S and ammonia, they are very strong odor. They have a very bad smell. So, that is why we get that bad odor near eutrophicated reservoirs. Methane doesn't have a smell. It's an odorless gas. But hydrogen sulfide and ammonia, normally hydrogen sulfide has a rotten egg smell. Ammonia also, you all know, it has an irritating smell. So, those two give rise to a very bad odor. So, this is the eutrophication process. Is it clear, students? So, now if we try to answer the question, here you can see a statement displayed on a board near a tank is shown in the figure. It is you who turn the water in this tank green. Yes. Why? We are the people who use agrochemicals, we use materials from the industries, then detergents, and also fecal matter. Sometimes when people take their cows or goat or anything near the reservoirs, the fecal matter that is also excreted into the reservoir, then all that contribute to eutrophication. Then you can see which of the following human activities in connection with the tank would have contributed most to the change mentioned on the board. First one, clearing the area above the tank? No. Just because you clear the area, it doesn't become green. Increase in algae population due to fishing? No. Just because the fishes are removed, there is fishing and less fish population doesn't mean the algae population will increase. Then accumulation of oil and grease due to vehicle wash, that doesn't directly contribute to the eutrophication. But there can be accumulation of oil and grease due to vehicle wash. Now, vehicle wash, if it is detergents, yes, but not oil and grease. Then addition of fecal and excretory matter to the water, yes, that gives rise to nitrates and phosphate. So, the correct answer here is addition of fecal matter and excretory matter to the water. So, those are the reasons. Industrial waste, agrochemicals, fecal matter and detergents. So, here but they have said oil and grease. Although it says vehicle wash, the substances added are oil and grease. That is why we are not selecting the third answer. If they have said detergents are added to the water, yes. So, that is why you have to read all the answers and you have to select the most suitable answer. For the 40th question, addition of fecal and excretory matter to the water gives rise to eutrophication. I am sure you all can understand that. So, with that students, I have completed this paper 1. That is the MCQ type questions. There are 40 questions. You can remember you have to answer all 40 questions. You have to select the correct answer or the most suitable answer and you need to mark it on the answer sheet provided to you all. So, before that you saw all the instructions. You have to read the instructions given on the question paper as well as the answer sheet. And you have to make sure students, you have to mark only one answer for one question. Don't leave out any questions. Do it neatly and also you cannot mark more than one answers for one question. I'm sure you can remember all that. So with that students, I'm going to end this chapter and in the next chapter, I will discuss the paper 2 of O-Level 2020 with you.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.